Honorable Chief Guest, Professor Paul Raj, Chairman, Board of Governors of IIIT-Delhi, Mr. Kiran Karnik, Director and ANTS 2020 Patron, Professor Bose, Chair of the Steering Committee, Dr. Dikshit, General Chair, Professor Srivastav, and TPC co-chairs, Dr. Bohara and Dr. Zilong, IEEE ComSoc team, authors, and attendees. A good morning to you all, and a very warm welcome to IEEE ANTS 2020. On a year when the whole world has come together to face a common challenge, that of COVID-19 pandemic, information and communication technologies have in many aspects led the way to restore sense of normalcy and purpose in our lives. Whether it's virtualized classrooms, dissemination of information, the remote work revolution, or digital entertainment, modern communication and networking technologies have become a key aspect of our lives. Following this new normal, ANTS 2020 has gone virtual. To inaugurate the event, I would request the dignitaries present on stage, Professor Bose, Professor Srivastav, Dr. Bohara, to proceed to the lamp lighting. Please. Thank you, everyone. I would request now our Chairman of Board of Governors of IIIT-Delhi, Mr. Kiran Karnik, to say a few words.
Thank you. Good morning to all colleagues in India, and good afternoon, good evening to colleagues elsewhere in the world. Welcome to this IEEE conference. Delighted on behalf of IIIT-Delhi to welcome all of you. I do wish you could have been here in person, physically, but unfortunately, given the circumstances, we have to do this virtually. But it's good to see participation and to see people around the world continue with activities as they are. And it is indeed a pleasure and an honor for us from IIIT-Delhi to be hosting this. Special welcome to our steering committee chair, Professor Dikshit, and of course my colleagues, Professor Anand Srivastav from the IIIT-Delhi as the General Chair, and the Director of the IIIT, Professor Ranjan Bose. And most of all, to our Chief Guest today, Professor Paul Raj, very grateful to him for taking the time to come and talk at this conference and agree to be the Chief Guest. Professor Paul Raj, as I just told you before we started, I'm looking forward to your physical visit. This is not a substitute for that. We hope to see you here soon. Just a few words. This is something which we've been very keen on in IIIT. We are comparatively a young institution, certainly as far as universities go. We are very young, just about a decade old, and we're trying to build up a strong research university. And part of our efforts are our continuing involvement with researchers, associations, and people around the world. And this is something which we see as being special. We also see our connect with industry as being very, very important. And therefore, this conference, which is looking at connects between the academia, industry, and the government to some extent, is a very important part of what we'd like to do. We see ourselves as an institution that does education on a research basis. That's a research university that continues to engage with society at the same time and look at relevant problems that we might deal with. And it's in that context that we've had difficult times, and this is where ICT, we have seen, has played a very, very crucial role in enabling a lot of activities to go on. In India, we've had, for those who are not familiar, a complete lockdown for many weeks, a really complete lockdown. No buses, no trains, no flights, no movement, really a lockdown. And what sustained the economy and what sustains people's ability to continue in this kind of lockdown was really the information and communication technologies. The ability to get things that you wanted at your doorstep by connecting and getting things on e-commerce, the ability to do financial transaction through e-banking. Most important, the ability to continue to work from home through these technologies was crucial to keeping at least a part of the economy going and also enable people to live with reasonable availability of things that were essential. In the course of time, within a few short weeks, the sense of isolation grew, and it was again really ICT that enabled people, even if only virtually as we're doing today, to interact with each other and continue, you might say, the social interaction via virtual means. And these were crucial examples of how technologies in this area have played a vital role. Frankly, none of these were new technologies. They existed for a long time, but their usage was minimal. And it's the COVID epidemic or the pandemic that forced us into using them far more extensively and showed both their versatility, their relevance, and how useful they can be. In the course of time, telemedicine, which again is something which has been existed for a long time but was not being used extensively, began to get used much, much more as people could not or did not want to visit a doctor and be waiting there, and teleconsultation took off. It's continuing in a big way now because even now people are hesitant to go certainly to hospitals, but even to their local physician, and they prefer using this virtually. So I think example after example of how useful this has been and how these communication technologies have played a vital role. A very important part of this is concerns about things as we've grown, a lot of these concerns about the network reliability, the network capability in terms of bandwidth, and how you can really manage to do this in an economical way in a country like India, where affordability is also a critical problem. So it's all of it, the usual triad you might see of affordability, availability, and accessibility from all points of view. The affordability from an economic point of view, certainly accessibility in terms of device and connecting to a network. And of course, very importantly, as I said earlier, the capability of bandwidth. And it's here that one has concerns because despite the network in India being extensive now, despite the fact that we're among the lowest cost in terms of data or voice, and in spite of the fact that the number of devices in this country is huge, the connections now are over 1 billion for a country of 1.3 billion, already over 1 billion connections with probably 600 to 700 million unique mobile phones, has really laid the groundwork for being able to do a lot. But that means high pressure on the network, and we have to continue to look at seeing how to upgrade the network, how as we've just moved into 4G, how do we go on to 5G? And then there are newer technologies, whether it is the Internet of Things that will possibly revolutionize everything we do, certainly in industry, but many, many other things, to really high delivery, high bandwidth capability for things like telemedicine, where you can truly get across so much, certainly in education, maybe in simulation. And these areas are going to depend more and more on the networks that we have. It's in this overall context of seeing how useful these have been, how relevant they have been for everybody from the common man to very advanced needs of industry or academia. We've seen how these are useful. And therefore, it's crucial that these networks that we look at are really as good as they can get, as cheap as they can get, and as relevant and easily accessible as they can get. And that's the context within which I want to place these deliberations from the point of view of what the social needs are. And of course, what drives this is the research and technology that goes on in academia, and in working with industry to see how these can quickly be transferred to actual usage through industry participation. I'm sure there's going to be a few days of really intense and very useful deliberations. Once again, I'm very, very pleased that we are hosting this as IIIT Delhi. We would like to be a major part of continuing dialogues in this area, and we would like to see how we can ourselves contribute. Thank you all once again, and a very warm welcome to the start of this conference.
Thank you, Mr. Karnik. I would now request our director and ANTS 2020 patron, Professor Bose, to say a few words about IIIT.
It gives me great pleasure to welcome you all to the IEEE International Conference on Advanced Networks and Telecommunication Systems, ANTS, being virtually organized at IIIT Delhi. We are very excited that IIIT Delhi is hosting this conference. Let me quickly share a little bit about IIIT Delhi. IIIT Delhi is a research-led teaching institute where our faculty members continuously work on cutting-edge technologies. For example, IIIT Delhi has recently started a new center of excellence on Li-Fi, the light fidelity, an upcoming research area, especially in the context of Indian developments. We at IIIT Delhi strive to be industry-facing, globally connected, and socially relevant. In this context, the theme for this year's conference, ICT for Connecting Humanity, resonates very well with us. How we have adapted to the new normal during this pandemic using ICT is a living example of how ICT and its allied technologies can be used to meaningfully connect humanity. In some sense, these technological advancements in communications and networking technologies gives a fitting reply and a good response to this pandemic. Our chairman, of course, referred to this in greater detail. As you know, this conference is designed to augment the interaction between industry and academia, and also serve as a mixing bowl of ideas related to academic research, industry initiatives, and governmental policies. The interactive structure of this conference widely and wisely uses tutorials, keynotes, invited talks, technical sessions, and panel discussions towards meeting this objective. We are delighted to have as chief guest Professor Arogyaswamy Paul Raj, Professor Emeritus, Stanford University, USA. Thank you, Professor Paul Raj, for accepting our invitation. It's always a pleasure to listen to you, and I eagerly look forward to your address today. I'm also happy to note that there is a special track on women in engineering in this conference. This is very important for us. Curiosity-driven research leading to discovery and the creation of new knowledge has been in the DNA of our communications research community since the very beginning. The gears of a research-led university interaction, the machinery that we have developed, and the gears that interlock well with the industrial development processes are essential for the success of this conference. Lately, our academic institutions have also set up vibrant ecosystems to encourage innovations leading to entrepreneurship. In this context, the IEEE ANTS conference will hopefully seed newer ideas, both out of the box and disruptive ideas, and aim to connect humanity and improve our daily lives. Once again, we are delighted that IIIT Delhi is hosting this IEEE ANTS conference, which is a conference of importance and repute. I would like to congratulate the entire organizing team for their effort and meticulous planning, especially during these changed circumstances. I wish all the conference participants all the very best in exchanging knowledge, ideas, and using that knowledge to increase the reach of ICT for connecting humanity. We would have loved to have all of you physically present on campus. Unfortunately, the circumstances do not permit that. But the invitation is open for all of you to please come and visit our beautiful campus whenever things normalize. Once again, I wish you a very productive conference. Stay safe, and most importantly, stay connected. Thank you.
Thank you, Professor Bose. I would now request the chair of the steering committee of ANTS 2020, Professor Sudhir Dikshit, to say a few words about ANTS 2020.
Good morning to all of you who are in India time, and also to people around the world in whatever time zones they may be in. Of course, we wanted to be physically at the conference site, but this could not happen. And lo and behold, when we were planning to organize the conference in Delhi, in India, we had chosen the theme of ICT for Connecting Humanity. This was way back in November, December of 2019, when nobody knew that we'll be hit with the coronavirus pandemic. But we certainly chose a very good team at that time, which has kept us connected and which has made it possible for us to organize this conference through the use of the internet technology. Imagine about 40 years ago, or 30, 35 years ago, this would not have been possible. So on my behalf and on behalf of the entire steering committee, which has 5 members in all, I'm very, very delighted to welcome you all who are present physically at the IIIT campus and those who are joining the conference virtually from around the world to attend this conference. This is the 14th edition of the conference. The first one was started in 2007 at IIT Bombay. At that time, it was a symposium or a workshop, but it has grown to a full-fledged international conference with full support from IEEE Communication Society, which basically means they take the responsibilities of the financial support as well. So over the last 14 years, the conference has grown in size and scope both. When we first started, our focus was mainly on networking protocols, quality of service, working on various stacks of the various layers of the protocol stack. But as we all know, that communication is not only about connecting, it also leverages many other adjacent technologies, which have now become part of the conference as well. And some of them are like content delivery network, cloud technologies, virtualization, security, web, AI, machine learning, applications, and so on and so forth, including the devices. So we now cover almost everything that has a role to play in communication and telecommunication technology and computer communications. Organizing a conference of this magnitude is never easy, especially when we have to go virtual. All along we wanted to have a physical conference, and that's what the organizing committee and our potential attendees wanted to do. So we debated for a long time whether to have a hybrid conference, those who can come locally or from the adjoining areas of Delhi, and those who cannot come, they can attend virtually. but there was no letdown of the coronavirus situation. So about 2 months ago, we decided to go entirely virtual. And this was the first for many of us, especially for our organizing committee members in India. And in 2 months, we had a lot of work to do, which was not easy. But they have put together an excellent program, as you will see from the agenda on the website. So our heartfelt thanks to IIIT Delhi, its management, and countless volunteers to make it a good conference, a good program, as you will see it on the web page. The 3 days will prove that they have done an excellent job. I especially thank Professor Srivastava, Professor Ghatak, Professor Bohara from IIIT Delhi, and Professor Liu from University of Essex. They are mainly the TPC chairs who really have to work very hard and dealing with hundreds of papers that are submitted, get their reviews done on time, and make sure that they're submitted as well, following the IEEE format and the requirements. And I also thank all the track chairs, such as the workshop chair, tutorial chair, WIE, which is Women in Engineering, panel chair, keynote chairs, and so on and so forth. They all have done an excellent job. And last but not the least, my sincere thanks go to Shirley Cisneros, who you will see in picture sometime in the morning, who is an IEEE ComSoc staff based in the US. She really led us through and put this virtual conference together. And she is the real force behind putting this virtual conference together. And she is managing all these rooms, and she really trained us all well to make it a great success. So now you can see Shirley there. So thank you, Shirley, for your great help and support. And she's here in the US. She'll stay up for the next 3 or 4 days, stay up in the nights to make sure that things are running smoothly. So with that comment, I'll close my talk. The rest of the details about the conference, as to the number of papers that were submitted, how many were accepted, about the various tracks that we have, you'll hear all those details from the General Chair and the TPC chairs. So thank you all again. Welcome to the conference, and please enjoy the conference over the next 3 or 4 days. And we'll take up the offer to visit IIIT Delhi in future whenever we happen to be there, or definitely during the next ANTS conference in 2021 in December, when we hope most of us will be able to travel to India. So with that, thank you very much for the opportunity to speak in the opening ceremony here. Thank you very much.
Thank you, Professor Dikshit. I would now request the General Chair of ANTS 2020, Professor Anand Srivastav, to say a few words and declare the conference open.
Good morning, good afternoon, good evening. Chairman, Board of Governors, IIIT Delhi, Director, IIIT Delhi, Chief Guest, Professor Paul Raj, Chair and Steering Committee, Conference Organizing Committee members, and virtual participants. A very hearty welcome to all the participants of IEEE International Conference on Advanced Networks and Telecommunication Systems, IEEE ANTS 2020, being held virtually this time. On behalf of the Organizing and Steering Committee, it is my great pleasure and privilege to welcome you to the 14th edition of IEEE International Conference on Advanced Networking and Telecommunication Topics. IEEE ANTS is financially and technically supported by IEEE Communication Society. The objective of ANTS conference is to learn and share knowledge among all participants. This international conference is a forum to bring together researchers, scientists, software, hardware architects, and industry professionals to discuss innovative ideas and diverse topics on next generation of telecommunication technologies and its applications. This is fostered through panel discussions, keynotes, invited talks, workshops, various technical sessions, where academia is exposed to state of the practice and results from trials and interoperability experiments. The industry, in turn, benefits from exposure to the leading edge research in networking, as well as the opportunity to communicate with the academic researchers regarding practical problems that require further research. The COVID-19 pandemic has affected the whole world, including our research community, in some unprecedented ways. Realizing many of you will have travel concerns as well as possible practical difficulties, and we have therefore decided to move the conference online. We are nevertheless excited to bring this conference to you, and we have worked hard to ensure that ANTS maintains its high standards and quality of keynotes, panels, oral presentation, and scientific papers and discussions. In the face of current global pandemic, people worldwide are stuck at home observing government social distancing guidelines. The interpersonal interaction that characterize humanity have been interrupted by this pandemic. It is now clear that COVID-19 is redefining society's relationship with everyday technology that makes socialization still possible. Pandemic has created a void, and innovation is jumping in to fill it. COVID-19 pandemic has certainly not triggered Industry 5.0. It has certainly brought home the reality of Industry 4.0. Digital workflows, robots, automation are no longer goals, they are requirements. Internet of Things devices have offered organizations a path toward preserving revenue streams during this pandemic. Other areas that have seen an uptick include e-learning, online education, e-governance, and e-commerce sector, with digital payments taking over a lot faster than the physical payment options. The pandemic has demonstrated the critical importance that telecommunication infrastructure plays in keeping businesses, governments, and societies connected and running. The sector has remained mission critical to keep economies moving. The current circumstances may accelerate the adoption of 5G to meet the demands of bandwidth, performance, and network slicing. There will be more focus on the sufficiency of networks to carry the significantly increased traffic as working from home continues to ramp up. Social distancing and self-isolation mean that telecommunication has become an elevated essential service. It is an opportunity for communication service providers, both mobile network operators and cable operators, to meet the challenge of their new critical role in the changed world to handle surge in the traffic of data and voice. In this virtual event, I'm sure we will all miss the social gatherings and the spontaneous delight of running into an old friend whilst wandering around the conference. It is perhaps some compensation that a virtual conference will allow us to sample a far wider range of topics than would have been possible at a physical event. The integrity and quality of the research and content will remain and now be experienced in different way. For this, I would like to thank IEEE Communication Society, IEEE ANTS Committee for putting its faith in IIIT-Delhi to host its flagship conference. While concluding, I take the opportunity to welcome each one of you and express my gratitude in your agreeing to participate in this 14th edition of conference. I am certain that you will have an exciting, stimulating, thought-provoking, and productive conference. Thank you for your support of our shared mission to advance technology for humanity. Thank you.
Thank you, Professor Srivastava. Next, on the behalf of the TPC co-chairs, Professor Zilong Liu, who is joining us today from Essex, myself, I would request Dr. Vivek Bohara to say a few words and appraise us about the technical program.
Good morning, good evening, good afternoon, wherever you are in the world. Thanks, Gaurav, for the introduction. On the behalf of TPC co-chairs, I would like to welcome you all in the inauguration ceremony of IEEE ANTS 2020. It is always a pleasure to hosting you either in person or virtually. This year, IEEE ANTS is different from previous editions in a sense that it is being held virtually due to the ongoing pandemic, and the role of TPC has become far more crucial since the technical sessions planning and execution, as well as invited speakers planning and execution, has to be done virtually. Before showing the paper statistics, I would like to thank all the authors for submitting their high-quality research work and imposing their faith to IEEE ANTS, as well as TPC members and anonymous reviewers for helping us in the review process. It's obvious without them, we would not have been able to complete the review process on time. So coming back to statistics, in this year IEEE ANTS, we received a total of more than 220 high-quality papers. The submission has come across all the globe, from USA to Australia, Africa, Europe, and Asia. And apart from that, we have papers from 32 different countries from all these continents. After a very rigorous review process, we accepted only 63 regular papers, 11 short papers, and 14 papers in Women in Engineering track. Apart from above, this year we also initiated an early career research forum wherein early career researchers, either BTech, MTech, or PhDs, can explain their research work, including work in progress, to a broader audience and gain valuable feedback from a panel of selected industry academia experts. The response has been encouraging, with 34 submissions across different disciplines. The authors include not only PhD students early in their research work, but also BTech and MTech students. This will help to inculcate research experience early in their career. Finally, I'd like to thank Dr. Abhijit, the PhD student, the Early Career Research Forum Chair, Dr. Gaurav, Dr. Zilong, my colleagues in TPC, and as well as Prof. Anand, General Chair, Dr. Dixit, Chair, Steering Committee, and Professor Bose, Director, IIIT-Delhi, for their continuous encouragement and support. Thank you. Thanks a lot. Have a nice day.
Thank you, Dr. Vivek. It is now with a great pleasure that I would like to introduce our chief guest, Professor Arogyashami Paul Raj. Professor Paul Raj is an emeritus professor at Stanford University. He is the inventor and pioneer of MIMO, multiple input, multiple output, wireless technology, and which is the key to all modern wireless communication networks. He has authored more than 400 research publications, several textbooks, and a co-inventor of 80 US patents. He founded 3 companies in the US, which were later acquired by Intel, Broadcom, and HPE. His recognitions include the Padma Bhushan from Government of India, US Government National Inventors Hall of Fame, the Friendship Award from the Government of People's Republic of China, the Marconi Prize, the IEEE Alexander Graham Bell Medal. He is a fellow of several national academies in arts, engineering, and sciences in the US, China, and Europe. Professor Paul Raj served in the Indian Navy for 25 years, where he developed the ASW sonar technology and set up new government R&D labs, namely CDAC, CARE, and CRL. He joined Stanford University in 1991 after prematurely retiring from the Indian Navy. With that, I would like to invite Professor Paul Raj for his talk. Thank you.
Mr. Kiran Karnik, Chairman, Board of Governors, IIIT, Dr. Professor Ranjan Bose, Director, IIIT. You are the host of this conference. And then, of course, to Professor Dixit and his team, which has put this conference together. It's been, I know, a lot of work. And also Ms. Cisneros, who has made sure all this comes together. So thank you all for your efforts, and thank you again for inviting me to say a few words. So it's a real privilege to speak to this event, though virtually, from Stanford University in California.
I thank the organizers for this invitation. The IEEE ANTS conference has a great program, and I congratulate the organizers, Professor Dixit and others, for their contributions. In India, like many other countries in the world, the COVID pandemic is once-in-a-century challenge. We all pray that India will soon be bounced back and be on track to build a united, prosperous, secure society for all its citizens and be true to the founding principles of a democratic, secular, inclusive, and a pluralistic country. My remarks today are on core information and communications technology, or core ICT as I call it, and to examine global trends in this ecosystem. I'll touch a little bit on India's status and aspirations in this area. My remarks will largely refer to the dominant civilian ICT sector and not touch on defense areas. So the information and communications technology is widely understood to be the enabling technology of the 21st century. ICT has transformed and continues to transform all aspects of our lives: commerce and finance, education, energy, healthcare, manufacturing, government, national security, transportation, communications, etc. IT and its impact on the global economy, both directly and indirectly, is assessed to be around $10 trillion. So it's almost 50% of the global GDP. So let me flash my first slide and talk a little bit about ICT stack. And so we can look at ICT in three layers. The top layer is the applications layer. So there are many verticals there: the economic verticals like banking and retail, then the societal verticals, healthcare and governance, and security verticals, defense and cyber. And all of them, of course, use ICT applications. And there are many good examples in India. Of course, we are really good users of ICT in India. These applications are in turn built on services offered by service providers, which could include wireless networks. We have Jio and Airtel and others. And then, of course, also cloud providers. There are many in India, including Tata Communications and many others. And of course, internet providers there are many internet providers in India, including local ISPs as well as the larger network providers. And these ICT services, in turn, are built on core ICT products. These include data centers, wireless base stations, routers, phones, laptops, etc. So let me switch to the next slide. But that's just an example of some pictures here. And I'm just, I'm showing off chips which I built long ago. These were chips at the SEAM Communications. These were LTE chips at the time that we got acquired by Broadcom. And but of course, there are big players, Intel, NVIDIA, and others. And a big part of all this is algorithms. And I know many of us in India contribute to this area, including Professor Bose, who's the director of IIIT. Right. So let me go on now, and we understand what core ICT is all about. It's all about hardware, embedded software, and it's really the layer on which everything else is built on. It's also very critical. The huge dispute or war between US and China is that US feels that China is potentially overtaking US in this area, and hence the big worry here in Washington. So the goal of the core ICT industry delivers hardware along with embedded software and firmware. It is, in a sense, the distillation of knowledge, of toil of millions of engineers and scientists. Sometimes this knowledge is formally disclosed through patents, and I'll talk about that later. So now let us look at the structure of this core ICT industry. And We can organize it in 2 layers. These are slides I flashed to the government, the Prime Minister's office and the PM several times. We can organize it in 2 layers. One is the design layer, where we have companies that design the semiconductors. This could be computer engines, or it could be AI engines. So a lot of effort there now. And system design, people who build routers, access points, servers, and server farms, etc. These are design companies. And then there are, of course, the example design companies could be Huawei or Cisco over here, and typically, say, Intel, NVIDIA, and also Huawei, and so on and so forth. The manufacturing layer, which is a layer below this, is the semiconductor fabs, which is a very important part of this layer because chips is as they call it in the US, the ultimate bargaining chip. Semiconductor chips is the driver for everything else. So their fabrication is very high technology. So this is the fabrication layer. And there are also advanced components, particularly in optoelectronics. Right now, this is growing in area. And of course, finally, the less critical layer is assembly and test. It turns out, despite these being very high technology, actually the assembly part is very low tech. And for typical examples of assembly and test are Foxconn and Flextronics. Sometimes Samsung or Apple have their. Apple does not. Samsung has their own, or tends to do their own manufacturing in the assembly plants. And examples are the semiconductor fabs. I think I mentioned before, TSMC, Global Foundries. We have in the area of systems, it's semiconductors. I mentioned names before. So you can get an idea of what this looks like. The total the revenue of this layer, of this all the 4 boxes here, is about 1.7 trillion, like 1.6 trillion. Is something is may have come down a little bit in 2020. My numbers are not very solid, but typically the system design layer, this box is about $300 billion of value addition per year. This layer, semiconductor design, is a little bit more, maybe 450 billion value addition. Semiconductor layers, maybe 420 billion value addition. Advanced component, maybe 100 billion. And assembly and test is, though low scale is pretty large, globally it's about 65 billion value addition. And a lot of this investment is not so much in the cost of labor, which are very low, very poorly paid, or very humbly paid, but all the equipment that's needed to do all this stuff, and including getting automated and robotized, a lot of capital investments. So the ICT layer is highly globally intertwined. It's useful to sort of look at the cost structure, for example, of a smartphone to understand how so. So here is an example of a smartphone, and the ASP and the product selling price is about $600. So that's some kind of brand. And if you look at it, you would find that the $600 of ASP, but $300 goes to this company XYZ, which let's say is Oppo. It could be Oppo, it could be Xiaomi, popular brands in India, or at least till recently. And so $300 goes to that company, and can be broken down approximately into $70 for the operations, managing the supply chain and everything else. $125 for R&D, the phone design, and some of the application software that go into it. And the balance for sales and marketing and profit and so on and so forth. The actual phone itself may be manufactured, that is by an assembly and test facility, let's say by a Foxconn under contract, and they'll probably get about $300. And for that, Foxconn itself will only get about $20, of which maybe $12 will go to for his own facilities and investments, and maybe $6 or $7 to the labor, who are usually not very skilled. We have many of them in India, manning factories I think in Hyderabad and in Chennai and so on and so forth. And the balance $280 goes to component suppliers, which $230 is probably semiconductors. Usually it could be from TSMC, or it could go to Samsung, Global Foundries, $35 for the display, and another $25 for the camera, components like camera and so on and so forth. So actually, Foxconn or the end manufacturer only makes about 3% of this end $600 price. Many companies come together to get this phone done. Put your phone in your hands. XYZ, let's say Xiaomi, the phone designer will source IP components and tools from about 20 other companies in order to put everything together. And those 20 companies, primary companies, may work with another 50 companies indirectly. So about 70 companies come together, and these companies are largely located in China, United States, Japan, Europe, South Korea, Taiwan, Israel, and Singapore. This is actually the core ICT ecosystem. So here is a picture of the ecosystem. I'm just talking only about core ICT now, and which is basically system design companies, semiconductor design companies, semiconductor fab, optoelectronic fabs, and of course neglecting assembly and test. And so with this understanding of how this whole thing comes together, it's interesting that if the total revenue of this industry is 1.7 billion, the actual R&D spend in this industry is about $280 billion a year. 280 billion is a lot. And in general, the view is, in order, for example, to get your smartphone in your hand, it wasn't done with, like, of the 280 billion, almost all of that is in human knowledge. I mean, there's very little value in anything else. It's human knowledge and human experience gathered over decades. Many of the top engineers have had 20 or 30 years of experience here. And so the view is that the actual underlying investments to build a modern product, a high-end phone or a router or a cloud, or blade for a cloud server, is probably $1 trillion of investments over the years. So it's a very high investment, very high skilled industry. And the core ICT is an interconnected system. No country is an independent island. The industry is very largely in the private sector. There are few examples, particularly in China, where the semiconductor companies, some of them have a lot of government investments. And elsewhere, it's all in private sector. It's only the only model that works because this is a super competitive system. And many of you who have started companies know that it's really you do or die. And I've gone through 3 startups, and almost no day I walk into the startup am I really sure whether the company will survive to the end of the day, because it's so competitive. And to any company to succeed in this highly globalized system, you really have to do better than the best. So if you're building, let's say, for example, my second company was building chips for wireless chips. I was competing with Broadcom, I was competing with Intel, and I was competing with Qualcomm. And unless you really have something better than those 3 guys, you cannot sell anything. So it's a very difficult system to enter for that reason. And so it's really an area of only it's very ultra competitive, and only the very best survive. And the winner takes all dynamics. That is, of course, is difficult for countries who are not in place to enter, but has brought us enormous value addition. If you have an iPhone or an Android phone in your hands, that represents an enormous amount of intellectual property at incredibly low cost. That's because of the competitive nature of this industry. So it served the community well, but it's a brutal industry to enter. So even though companies, successful companies operate globally, whether it's Intel or whether it's Samsung or whether it's Huawei, they're all over the world, they remain under the control of the country's government where they are headquartered in. So Huawei is controlled by the Chinese government, Intel is controlled by the US government, and Samsung is controlled by the Korean government. And the home government is motivated by national security matters or geopolitics, can prescribe the company's international operations. The US government recently restricted access to US technology to several companies in China because it served US's global geopolitical needs. Even ironically, even if company A designs a piece of technology in an offshore R&D operations in country B, country A can still be blocked from selling. The company A can still be blocked from selling technology to country B. So the headquarters of a company is very critical because the government can assert global controls. And there are, of course, huge entry barriers into this ecosystem, massive accumulated knowledge and IP, standard essential patents. This is a big area. High-end, very risky environments for startups. Typically, in the Silicon Valley, the headquarters of all venture capital is just half a mile from my house here. I'm speaking from Sand Hill Road, and only about out of 10 inventions we make in startups, so only five will definitely be dead. 2 or 3 may just be living dead. Only 1 or 2 survive, but usually the ones that survive do very well and they make up for everything else. But it's very high failure rates. And there are lots of now technology and trade and technology barriers coming in and so on and so forth. So it's a difficult area to enter. But I think once you enter, it's a very good place to be in because ICT is really the mother of all, is the core infrastructure for the modern world. And every country, particularly in India with 1.3, 1.4 billion people, should aspire to join this ecosystem. So just to look at 5G patent families, this may not be the most latest, but these are the patent families recognized by 5G. We can see quite a lot of companies here. There are none from India, but it's heavily China dominated. I think for 18,000 patents, 72% are China. Of those Chinese patents, 35% are triadic patents. That means these are the most useful patents that they are filed in the Japan Patent Office, US Patent Office, and the European Patent Office. Typically, a triadic patent, I have filed a few in my own companies, cost almost 1 crore each because of the enormous cost in filing in these areas and translations, maintenance. It really costs $100,000 each before they become valuable. So you can imagine the amount of billions of dollars that's invested in this area just to get the patents done, leave alone all the intellectual property generation and engineers required to build these patents. So now let's talk a little bit about India. So we made some very impressive achievements in the early 50s, 60s, and 70s. Mr. Kiran Karnik will know all about this, but I think many of you or others are very young here. But for their sake, at least let me go through it. India actually, when we became independent, emphasized ICT enormously. The very first public PSU was ITI in Bangalore. That's Prime Minister Nehru inaugurating ITI. I think the Vice President Radhakrishnan was there. And of course, those days ITI was highly mechanical for good reasons. And then, we were fortunate to have Dr. Homi Bhabha, was very influential with Pandit Nehru, and he started TIFR, and we built a computer called TIFRAC. I think Kiran will know about it. It was generally acknowledged to be one of computer with lots of advanced architectural ideas. And M.G.K. Menon, who was the director of TIFR, later on became the chairman of the Electronics Commission. So he gave a great push to try and indigenize, become self-reliant electronics. And then around the 1980s, we had Sam Petroda, all of you know about. He came to India and built CDOT, really a great achievement. And after about 1991 or so, due to various reasons, we realized that our technology in India was not competitive with the world. So we had to really give up, and we opened our markets to the world. And after that, I think there was a big decline on whatever was going on in our country. And that is a challenge today, is to rebuild that. We really went into decline the last 30 years. And but there were, I would say, some interesting achievements, and that is TIFRAC in the 1960s I talked about. This was, you may not know about it. This is probably a secret project, but only a few pictures available. This was a sonar which I built, which I headed in the 1970s. A very, very large system. Yeah. These are the three operators running it, and I'll speak a little bit more about it. And this is the DSS Max built by CDOT, 1980s. It was a very large switch. I think something like 150,000, 100,000 lines with a huge, very, very well designed, went into the network. And I think we actually served 30 million lines on Indian network with this switch. Of course, telephone switching, of course, went out of favor. So this product didn't move forward very much. Let me talk a little bit about APSO, the sonar. This is a very large system. This is, I don't have a block diagram APSO to show because it's a secret. But this is SQS-26, the US sonar, actually earlier generation. APSO was very similar to this, but one more generation ahead. And it's a very large system. In those days, many, many millions of dollars with 3 displays, a huge transducer. This is about, cost about weight about 6 or 7 tons. It has its own chilling plant for all the cooling electronics. It has its own power plant for 100 kilowatt of pulse power, and a very, very large system. And it turned out that this APSO turned out to be actually the ahead of anything we saw available to us from the Soviet Union and Europe. We were buying sonars from them, so we are certainly very beyond them. And there was reason to believe that we had probably matched the capability of the United States in that area. And that was remarkable because in the 1970s, because of the Cold War, nuclear-tipped submarines were the biggest worry between the Soviet Union and the United States. And sonars was the critical technology to have. So today, a lot of top students, US, go to communication firms to build 5G and so on and so forth. In the 70s, it's sonar that attracted that talent. So it was a very high priority area for Soviet Union and the United States, and we in India were able to match it, if not exceed it. So we did many good things, but I think when you opened the economy in the 1990s into the world markets, our investments could not keep up, and we fell behind. So let me say a few words. So where is India today? We probably consume about $55 billion of core ICT in our country per year. This is my guess for 2019. It's very hard to come by reliable numbers. And this is excluding defense. And the local value addition in core ICT is very, very small. We, of course, India, let me go back and look at the stack again. At the top of the stack in applications, we've done very well. Paytm, Ola, we have the payment stack. Mr. Kiran Karnik is an architect behind all these advances. And we have a healthy mix of foreign companies too, Facebook and others who operate in India. In application layer, I think we've done well. We probably have to build a little, in my opinion, more social media companies in India, but generally we're in a healthy situation there. In services, actually, we've done extremely well. Our cost of wireless, I'm recently on 2 calls the last 4 days within US, worrying about the fact that 15% of United States people don't have internet access. 10% have no internet access at all. In some states, Mississippi, 30% don't have it. And in India, we've done much, much better. And one reason is very low cost of services. $1, $2, and $3 ARPU. So we do that with the same equipment that we use in the United States. So it's really remarkable we've done well. Services, I think we've done extremely well. And we have some operators like Amazon, others who provide cloud services. But this is also a healthy segment. And not to forget, we have an engineering services segment where we also build software for the application layer. But we also serve many companies in this layer and in bottom layer. The bottom layer, of course, is the core ICT layer. Here we have virtually very little presence, almost zero. And of course, we tend to be dominated by Samsung, Semiconductor, Cisco, Intel, Huawei with their tools, but now there's some questions about Huawei entry to India. But this is an area where India has not done well. We were actually in a reasonable shape till 1990s, but after the last 30 years, there's been a decline. So there are lots of good things happening, but this is an area we need to push this back and get more participation from Indian companies. So given all this picture, what we need to do in India is to, where should India be? And I think but before I go to this, let me talk a little bit about, take a few more minutes, talk a little bit about India's situation in R&D. Our investments in R&D are still low. We actually spend, according to PSA's office in Delhi, about 13 billion. Half of it goes to defense. We spend about 6 billion in R&D in all other areas, in civil areas. My guess is that the core ICT probably attracts maximally about $1 billion, probably less than that, much less, both public and private sector. And while global investment in this area is in core ICT is 280 billion, so it's a big gap. So what should be a reasonable goal for us in core ICT? I think and this is what I've been pushing at the Prime Minister's level, that we should try and aim for something like 5% of the global market share in 10 years. It'll take about 10 years to go there, but even to get to 5% is we got to grow close to 100% a year for many years. And in 10 years, the global ICT will be about 4.5 trillion. My guess, maybe 4 trillion. So 5%, 6% will take us to about $200 billion. The $200 billion of revenue added by Indian companies. But of course, those companies will have become multinational. There's no company can survive just selling within one country. So we got to build multinational companies headquartered in India and join the other multinational around the world in this ecosystem. So India too should be a part of the system. And this is a tough goal, but I think it can definitely be done. We have very, very talented people in our country. I certainly know them well. What I've been pushing for the government is that I think we need an apex body like a commission to look at this industry carefully, look at all the barriers we've faced, the reasons why progress has not been good in the last 30 years, and for that body to operate, we must understand the ecosystem properly, look at all the various barriers, and make government policy to help the industry. Industry, of course, will be mostly in the private sector. We may have a joint sector in semiconductors. So I think it is that lack of understanding of the industry that I think has made the government policy less effective than it's been. So I absolutely believe that India, with an empowered core ICT industry, can attract the talent it needs. We have a huge amount of talented people, and to accelerate the critical technology. and our the contributions to the world will be very welcome, because we need more and more innovation here. And every good idea that India can bring, every innovation it can bring, every essential patent it can bring, adds to the pie, not subtracts from anything else. So core ICT is not a zero-sum game. The world welcomes India's innovators and entrepreneurs to help advance its technology for benefit of all mankind. So with that, I'm sure that we are now heading in the right path, and I'm certainly will be back in Delhi soon, saying my piece. But it's important for everybody in this conference to contribute to this technology, and certainly to India to take its rightful place in the world of things. Thank you very much.
Thank you, Professor Paul Raj, for this insightful talk. I would now request Ms. Shirley Cisneros from IEEE Communications Society to say a few words about IEEE and IEEE ComSoc.
Good day to all. Thank you. I am Shirley Cisneros, ComSoc Staff Planner for ANTS 2020. On behalf of IEEE Communications Society and the ANTS Organizing Committee, we welcome all and are grateful for the attendance, and we are thrilled to begin this conference. ANTS is fully sponsored by IEEE Communications Society, and as many may be aware, IEEE ComSoc is a leading global community comprised of a diverse set of professionals with a common interest in advancing all communications and networking technologies. IEEE ComSoc has over 28,000 members in more than 149 countries. Membership is up by nearly 8%, with a strong growth in higher grade memberships and student memberships. Please visit our website, comsoc.org, for more information on membership opportunities, as we also offer discounted packages for students. We have many things to look forward to in 2021. Our strategic plan is well underway with the support of our current president, Vincent Chan, and our board of governors. We have three main areas of focus. One is to reshape the technical balance and expand the portfolio. This will encompass physical to application layers, include computing, signal processing, explore and incorporate new tools, example, AI, cognitive techniques, analytics, energize, reshape technical committees and emerging technology committees initiatives. Two, re-engage industry and recruit new members. Lastly, we continue to promote diversity in gender, geography, and discipline in leadership positions. Again, we invite all to visit comsoc.org for more detailed information. Additionally, we welcome all to explore our diverse conferences portfolio, which includes over 39 plus conferences worldwide. Thank you again for your valuable time, and we hope that 2020 IEEE ANTS brings greater knowledge to all. Without further ado, I hand back the floor. Thank you again for your time.
Thank you, Ms. Cisneros. Thank you, everyone, for joining in. Thank you especially to Professor Paul Raj for the insightful talk on ICT and the way forward. Finally, we would like to conclude the program with an introductory video about IIIT-Delhi and ANTS to kickstart ANTS 2020, ICT for Connecting Humanity. Thank you.